find is that, and I've kind of normalized voltage here with respect to different parameters like thickness and shear modulus of the solid and its electric permittivity. Regardless of kind of how you want to show this curve, the bottom line is that you apply all this voltage, kilovolts, okay? Like, 1 kilovolt, 2 kilovolt, nothing happens. And then suddenly you apply, say, 3 kilovolts, suddenly you see a little bit of change in thickness. And then you go to, like, say, 4 kilovolts, okay? And then you get this instability, okay? This electromechanical instability, where suddenly you go from having basically no actuation, no response, to suddenly complete collapse and failure, okay? And this is kind of catastrophic failure in the sense that you can't use your actuator after you've undergone this instability. In fact, before you even reach this instability, what typically happens is that the voltages will be so high that you'll get either electrical arcing around the insulator, or you're going to get dielectric breakdown through the insulator. Okay, and so just to kind of demonstrate that, again, this is kind of a demo for the soft robotics class, but this is the dielectric elastomer actuator, where I've basically had some natural bending curvature due to that kind of pre-stretch of the dielectric film. I apply 2 kilovolts, you get very modest deflection, okay? I apply 3 kilovolts, a little bit more, okay, so that's kind of promising. But now when I go to 4 kilovolts, you'll see what happens, okay? So when I go to 4 kilovolts, now I'm getting very large deflections, okay? But then I get, you saw that spark there, I got that dielectric breakdown, okay? And basically I fried this actuator at this point, okay? So the kind of lesson here is that when it comes to using these materials, they have a lot of great advantages in terms of the simplicity of fabrication, in terms of their incredibly high efficiency, okay, their low power requirement, the potential for very high speed. Okay, I kind of intentionally kind of loaded this slowly, right? There's all these advantages, but one disadvantage, right, is that we have